Okay, welcome back to Mr. Hassan's Maths channel. I'm going to go through now question number 2 from the January 2015 International A-Level Mechanics M1 paper as requested by one of the students on YouTube. And this question here is about a block of mass 50 kilograms which lies on a rough plane which is inclined to the horizontal at an angle alpha where the tangent of alpha is equal to 7/24. The block is held at rest by a vertical rope, as shown in figure 1, and is on the point of sliding down the plane. The block is modeled as a particle, and the rope is modeled as a light and extensible string. Given that the friction force acting on the block has a magnitude of 65.8 newtons, find for part A the tension in the rope. Okay, so there's a few important points here. Probably the most important point is, or one of the important points is that it is, the block is held at rest. Okay, it's held at rest. So the resultant force acting upon it is equal to 0. Okay, it's not accelerating up or down. It's held at rest. But it's on the point of sliding down the plane. So it's just about to slide down the plane. Okay, there's a rope that is holding it up. Okay, which has a tension in it. If that tension was decreased, it would slide down the plane. Okay, it would slide down the plane because on the point of sliding down the plane, it's just about to. So whoever's holding up this string is holding up this string with such a force that it's just enough to stop it sliding down the plane. Okay, and if it's reduced any more, it will slide down the plane. Okay. Now, the block is modeled as a particle and the rope is modeled as a light and inextensible string. Given that the frictional force acting on the block has a magnitude of 65.8 newtons, find the tension of the string. So, of course, they've told us now about a tension, a force acting, a frictional force acting, and now the frictional force is going to be acting up the plane because this thing is about to slide down the plane, and what's stopping it is the friction and also this string. Okay, so the friction now is acting up the plane. When it says it's on the point of sliding down, that means it's just about to slide down, and it's a rough plane. That means friction must be acting in the opposite direction, preventing it from sliding down. If the question said it's about to slide up the plane, then the friction would be acting down the plane because it's about to slide up. So friction is trying to stop it from doing what it's about to do. So here the friction is trying to stop it from doing what it wants to do. It wants to go down the plane, so it's going to be acting. Friction is going to be acting up the plane. Okay, so that's very important for us to realize. Okay, so what I'm going to do is I'm going to take the diagram and make it a bit bigger, and so I can show you certain things that are important. So I've got the same diagram down here. So as we mentioned, this is the tension. We also have the friction. That's frictional force acting, which they told us. Okay, I will discuss that in a minute, a bit more detail. And we also have the weight of this object, which is acting down the plane. Okay, not down the plane, sorry. The weight of this object, which is always acting vertically down. So I'll just start drawing it from here so it's in line. So it's acting vertically down. So this is, you could say, the weight of the object acting vertically down. Okay, that's the weight. So the weight is 50 times g, 50 times the acceleration due to gravity. So 50 g newtons is the weight acting straight down. And there's another force when two surfaces are in contact with each other. Then you have basically a force which is called the normal force. The normal force is when these surfaces are in contact with each other. So you're going to have this normal force which is acting perpendicular to the contact, to the surface of contact. So it's going to act perpendicular to the plane. So I'm going to call that the reaction force R. Okay, that's the reaction between the surface and the block. That's perpendicular to the plane. So these are all the forces that are acting on this object. You have the tension in the string, you have the frictional force that's preventing it from going down, you have the weight of the object, and you have the reaction force between the block and the plane. Those are all the different forces acting on this object. Now, what I'm going to do next is I'm going to resolve these forces such that they are all parallel and perpendicular to the plane. Now, the reaction force and the friction, they are both already parallel and perpendicular, so I don't have to resolve those. But it's the tension and the weight I have to resolve in a direction perpendicular and parallel to the plane. Now I know that the angle here is alpha. So, and we know that the tangent of alpha is equal to, as they told us, 7 over 24. Okay, so if I know that this angle is 7 over 24 for the tangent of this angle, I can find the cosine and the sine of the angle pretty simply as well. Because I know that if I drew a right angle triangle, and if I know that this angle is alpha, and the side, if it's a right angle triangle, this side is 7 and this would be 24, that the tangent of the angle would be 7 over 24. So I can work out the hypotenuse of this side using Pythagoras. I know it's going to be 25. That's because it's one of those special Pythagorean triples where 7 squared plus 24 squared square rooted gives you 25. It's like 3, 4, 5 and like 5, 12, 13. There's a few of those numbers which are called Pythagorean triples, which are normally used in these type of questions. But anyway, that's the tangent of alpha is 7 over 24. That means the sine of alpha is going to be 7 over 25. So we say the sine of alpha is going to be 7 over 25. And the cosine of alpha is going to be 24 over 25. Now that's going to help us later on when we are working out cosine of alpha is 24 over 25, 7 over 25, and cosine of alpha is 24 out of 25. So those are going to help us, especially these two. We're going to need them when we resolve the forces. So now let's resolve the forces. So I'm going to draw in the components of these forces such that they are parallel and perpendicular to the plane. So let's start with the weight. This is F50G. Let me draw it so that it's perpendicular. Let me just draw it so it's like over here. That's perpendicular to the plane, and then the component will also act down the plane. That's going to be the component of the weight down the plane. Okay, so that's going to be, let me draw that a bit higher up so you can see it better. So this is 50G times, well, let me just first explain how we resolve the forces. Now, I know that this angle here is the same as this angle here. Now, some people don't understand why. They just write it down. Okay, but I want you to understand why. It's always best. So what we can do is you compare this triangle here, which has a right angle this place, and this big triangle that looks like this. Okay, this triangle here made with the component of the weight going perpendicular to the plane, which has a right angle over here. So if you compare these two triangles, this big triangle here and this little triangle here, both of them have a right angle in these two places, and both of them share this angle here. This angle is in this little triangle, and this angle is also in this big triangle. So you can say that two of the angles in this triangle are the same. These two angles are the same in this triangle as these two angles in the big triangle. That means the third angle must also be the same in both of them. So that must be alpha. Okay, so that's the reason why this is alpha. Okay, so I hope that's clear. That's why that's alpha. So this is alpha here. Okay, and if I look at the tension, I want to also resolve that parallel and perpendicular to the plane so that I can work out my forces. So the tension will also have a component which is parallel. I'll draw it up here, parallel to the plane, and also have a component which is perpendicular to the plane. Okay, and we can see that this angle between these two is the same as this alpha, because like it's the same as this angle here. They're vertically opposite. Okay, vertically opposite angles. So this is also alpha. So if I want to resolve the 50 newtons perpendicular to the plane, I have this line has to kind of like go into the angle to reach this component. So it's going to be 50G. If it goes into the angle, it's always cosine. So 50G cosine alpha. You can think of it as I need to find what this part of it is. If we make this into a right angle triangle, then this would be the adjacent side. So I'm going to use cosine. And if I want to find the component of the weight going down the plane, this line of force has to go away from the angle given. So in that case, we're going to use cosine. So this is 50G. Sorry, in that case, we use sine. So that's 50G times the sine of alpha. And we can kind of think about it as we want to resolve this force kind of parallel to the plane, so in this direction, and this side is like the opposite to the angle, so we're going to use sine. Okay, so that's how you can maybe think about it. And similarly for the tension, I want to resolve this tension parallel to the plane. I have to go away from the angle given, so again that's going to be the sine of alpha, t times the sine of alpha, and this I want to resolve it going up the plane, or sorry, perpendicular to the plane, so that's going to become t times the cosine of alpha. Why? Because I have to go into the angle to resolve it in that direction. Here I have to go away from the angle if we resolve in that direction. Here this line of force has to go into the angle to resolve in that direction. So that's cosine alpha and that's sine alpha. Now I have all the forces and the components of any force that's not perpendicular and parallel to the plane marked on my diagram, and I know the value of the tan and the sine and the cosine of alpha. I can now proceed to answer the question, which says find the tension in the rope. So to find the tension in the rope, what I will do here is I know what F is. They told us what F is. They told F is 65.8. Okay, so I know this. I know what alpha is. So the only thing I know the weight is. So if I resolve my forces parallel to the plane, I think the only thing I won't know is the tension. So if we resolve it parallel to the plane, in fact what I'm going to do is I'm to resolve it parallel to the plane in such a way that we're going to take down as positive. It doesn't really matter because this thing is in equilibrium, but just, I like to take the direction that something's moving or the direction that something is trying to move as the positive direction. So this is about to slip down the plane, so I'm going to take down the plane as positive, parallel to the plane going down as positive. In that case, 50g sine alpha is equal to, because it's an equilibrium, t sine alpha plus f. Okay, plus f. And I know that f must be its maximum limiting value, okay, which is 65.8 newtons. Okay, because it's about to slide down the plane. That's a maximum it can reach. All right, they told us what the tension is, the friction is anyway. So for this particular part, we don't really have to even consider that too much. But I can find what F is now. I can find what T is now because I know what F is. So if I just replace everything, in fact, what if I just rearrange this a bit? I'll have 50 times 9.8 times the sine of alpha. Now I know the sine of alpha is sine of alpha was 7 over 25 times the 7 over 25. Okay, so that's going to be like this. That's all of that equals t times 7 over 25, so 7t over 25 plus f, which we know is 65.8. 65.8. So the only thing we don't know is the t here. So if I calculate all of this, so let me just put this in my calculator. I have 50 times 9.8 times 7, and that's all over 25. Okay, that gives us 137.2. All right, 137.2 minus 65.8. I'll take away that from both sides. And what I'll also do is I'll multiply this by 25 and divide it by 7. And that will leave me with my tension. So I'll just do that in one go there. So I'll take this value, which is the subtraction that I've done there. I'm going to take away from this 65.2, 65.8. Okay, that gives me 357 over 5, which is 71.4. I've got to multiply that by 25 and then divide it by 7. And I get 255. So therefore my tension is 255 newtons. And there's my answer. I can leave my answer to 2SF. I can leave it as tension equals 260 newtons if I want to. That's acceptable because we use G as 9.8 as we're instructed to in the question. In the beginning of the book, beginning of the exam, sorry, the instruction says you can take G as 9.8, which is to two significant figures. That means our final answer doesn't have to be, to a higher degree of accuracy than two significant figures. So they'll accept both of these answers. I would stick to 3SF myself because it's acceptable for all the different types of questions. But if you write this, if we've used G in the calculations, if you write it to 2SF, it's also completely acceptable as well. So both of those are perfectly acceptable. And there's the answer to part A of this question. Okay, so we resolve the forces parallel to the plane to get this equation. All right, so now for part B, what we have to do is we have to resolve the forces perpendicular to the plane, because part B tells us to find the coefficient of friction. So I'm going to just take this diagram to the other page and then we'll continue. So question part B says find the coefficient of friction between the block and the plane. Okay, so as I mentioned, we now need to resolve the forces perpendicular to the plane, because we know that the coefficient of friction is F, the friction, or the maximum friction, is given by mu times R, right? So we want to find what mu is. Now we know F max already. Okay, they gave it to us, and the question was 65.8 newtons. Let me just make sure of that. 65.8 newtons, right? And we also know, or we can find what R is. So this is 65.8 newtons. Okay, if I find what R is, then I can find what mu is, because mu is going to be F max over R. And why is it F max? Because it's on the point of sliding, so it's reached its maximum amount. The friction can't go higher than that, because this is just about to slide. If we reduce the tension, the friction won't increase anymore to stop it sliding, because it's reached its limiting value. That's why it's just about to slide. Okay, so we've reached the maximum friction, which is 65.8. That means mu is going to be the friction they gave us, which is the maximum friction over R. So now our next objective is to find what R is, the reaction force. If we find what R is, therefore we can find what mu is. So let's find what R is. Let's resolve these forces now perpendicular to the plane. So in that case, I have R acting perpendicular upwards. Then I have T cosine alpha, so plus T cosine of alpha, also acting vertically upwards in the same direction as R. But then I have the component of the weight. So that's the component of the tension acting vertically upwards. This is the component of the weight acting vertically downwards. It's an equilibrium. It's not moving up or down. So you're going to have, this is equal to 50 times G cosine alpha. Okay, so now we can find what R is. I know what T is already from the first part of the question. We just found T is equal to 255. What was it, 255? Yep, 255. So we know that T is equal to 255 now. 255 newtons, and we know that F max is 65.8 newtons. Okay, so we have everything we need to find what R is. So we can say R is equal to 50 times G. Now the cosine of alpha, as we discussed before, is 24 over 25. So we're going to use it times 24 over 25. So I'll use G as 9.8. 50 times 9.8 times 24 over 25. Okay, that's this, minus T cosine alpha. As we mentioned, T is equal to 255. So 255, again, times 24 over 25. And that will be the value of R. So let's find what that gives us. So we have 50 times 9.8 times 24 over 25. And we got to take away from that 255 times 24 over 25 times 24 over 25. And that gives us, whoops, what did I do wrong here? Let me just, that's 24, not 25. 24, let me put it over 25 like this. That's better. Okay. And that gives us the value of R, which is 225.6. 225.6 newtons. So we can write, we don't need to round this because that's not our final answer. So leave it like that. We're going to round the final answer, which is mu. So mu is equal to F max over R, which is 65.8, which is what they told us. 65.8 divided by R, which we know is 225.6. And if we take 65.8 divided by our answer, that gives us 7 over 24. So we can leave it at 7 over 24 if you want. We could also write it, if you want, to 2SF or 3SF. So we could say mu is equal to 0.292, sorry, 0.292. Or we can write it as 0.29, or we can leave it as a fraction. All of these are acceptable answers. You can have it 2SF, 3SF, as a fraction, that's fine. All three are acceptable answers in this type of question, and that's part B done. Okay, so basically these type of questions on statics and even dynamics, when you have planes, and what you have to do is you have to try and consider all the forces acting on the object, and you have to try to resolve them in the direction of motion and perpendicular to the direction of motion. If it's not moving in the direction that it wants to move, okay, which is always perpendicular and parallel to the plane. Okay, so it's going to try to move somewhere parallel to the plane, so you resolve the forces parallel to the plane and also perpendicular to the plane. Okay, so that's how you always deal with these questions. And when you resolve those forces and set up your equations of motions, like, you know, we resolve the forces parallel, that helps us to find what t is. We resolve the forces perpendicular, that helped us to find what r is. So you have to just, when you do that, that's the majority of the marks from the question, just from that resolving. Even if you don't get the right answer in the end, the method of resolving the forces, and setting up these two equations is what's going to get you most of the marks for such a question. All right, so it's very important. So the important point in this question is also the fact that it says it's on the point of sliding down the plane. That's the key for us to understand that the friction is going to be acting up the plane. Okay, if it was saying that it's on the point of sliding up the plane, then friction will be acting down the plane. That's the important point in such questions. A lot of people don't understand how to draw the friction in such questions. Okay, but you have to think about, if it's on the point of sliding, you've got to think it's going to slide down. Yeah, friction is going to try to oppose it. It's going to slide up. Friction is going to try and oppose it and act down, and so on. Okay, so other questions from this paper that I've answered, you'll find in a playlist that should appear somewhere in this area over here. Other questions from statics and from M1 statics, you'll find in this playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.